Hi, everyone. I think we'll just give people maybe a minute to dial in. Okay, I think we can just go ahead and get started. Um, Good afternoon, good evening, wherever you're dialing in from. My name is Ananya, and I am looking after sales for the MENA region at OneclickLCA. And I'm very excited to be hosting this session from concept to carbon, introducing LCA in early building design with KGBC, who really have been forerunners in sustainable building practices in Kuwait. Their work has definitely played an important role in pushing forward conversation around sustainability in the region. Welcome. And this is particularly a relevant conversation for the region, Middle East as a whole, as well as South Asia, where we are seeing a lot of momentum around green building frameworks, certification systems, and emerging carbon-related regulations. At the same time, there's a growing need for life cycle assessment and the thinking into day-to-day sort of design decisions, especially early on in the projects. And so today's session will focus on LCA, specifically embodied carbon, and how that can be integrated into decision-making right from the concept phase, where the biggest opportunities to influence the outcomes still exist. And we'll also be looking at LEED V5, which is one of the biggest updates from the certification body in the last decade. And LEED V5 will be a requirement moving forward. So it'll be a good overview on what to think about as project teams plan for the rest of 2026 and onward. We'll also be looking at how LEED was utilized for a project in Kuwait. So we have a live case study that the KGBC team will share in this webinar. And before we begin, just a quick note that we'd love to have this as interactive as possible. So if you have questions that come up as we walk you through LCA, just feel free to drop in your questions in the chat and we'll be answering them. We'll also have a live Q&A towards the end. Yeah, and with that, I will introduce our speakers. We have Ms. Dalal, who is the General Manager for Kuwait Green Building Council. And then we have Marios, who is leading LCA consulting at OneclickLCA. And yeah, I'll pass it off to Ms. Dalal to just introduce KGBC and then for Marios to take on. Thank you.
Thank you, Ananya, for the introduction. I mean, we're very excited about this event. This is our second collaboration with OneclickLCA. I really want to thank everyone who registered to attend this event, but I really want to thank you, OneclickLCA team, for your openness to collaborating on creating these events. I first have to acknowledge that we're doing this event in very extraordinary circumstances in Kuwait and the region. And although some people might brush the discussions of sustainability aside, I find it at the heart of the situation. Making conscious choices, raising awareness on and how to make our environment, our buildings more resilient and more sustainable is at the heart of these conditions. So as Kuwait Green Building Councils, we've been aiming to create events around these topics, but also give our stakeholders, whether they're companies or professionals, the tools to act more sustainably in their roles. And I think one of the biggest and most important tools that we recognized early on was life cycle assessment. And this is why we collaborated with you last year in May in doing a workshop here in Kuwait on this topic. I think definitely this is a topic that will gain momentum over time, especially with the introduction of Lead V5. So we're very excited and looking forward to this discussion.
Thank you very much, Dolores. Yeah, so hello, this is Mario Sikos from OneclickLCA. I will be presenting the next few slides today about lifecycle assessment, LCA throughout the design process. We will focus on earliest design stages, and of course, we will see a quick demo of OneclickLCA to see this in practice, like how do we do all these things. Before we start, some very quick words about OneclickLCA, who we are and why we're here. We pride ourselves as the #1 construction LCA platform in the world. We've got pretty much all top architects, engineers, and manufacturers using our platform to decarbonize their projects and products. We offer a platform that will allow you to comply with local regulation certification schemes like LEED version 5 that we will look into today, and give you access to pretty much any data, environmental product declaration data in the world. So it allows you to do an LCA in any part of the world, really. And there's plenty of features to make your life easier as well. Unfortunately, we don't have enough time today to go through any of those integrations, but as we will see, most of the time when we're doing a building LCA, we're spending in gathering data, building material data, design data. So with all these integrations, which is just some of the integrations that we've got available, you can speed up the process. You can get the data that you need. For example, Autodesk Revit, which is probably the most popular BIM tool in your region. You can get everything that you have already spent the time to model and proceed with a quick carbon assessment and use the results later for the actual analysis. But as I said, not enough time for this kind of technical stuff today. So let's move on. So what we were talking about today, we're focusing on the theory of LCA, like what it is. It is important to get a good understanding of what it is, to understand why it is important. We will see how we can do this and why it is important to do this throughout the design process. We'll look into some rating schemes and then why it is important to start early at the earliest design stages, and then a quick demo that I forgot to add in the agenda. So we will close with that. But yeah, before we start, I believe that there's going to be a poll which will ask you what industry are you working in. It will be really interesting to get some insights from you. I can see it in my screen, so I will skip it myself. And
sorry, Mario, as you're
yes,
just giving the audience a chance to answer this question, I just wanted to check if everyone can hear us. I just saw a note saying that they cannot listen.
that is a very good note and kind of important.
Maybe you all can give a thumbs up
Yes,
that you all
okay.
can listen to us. Okay,
Okay,
great.
awesome.
Thanks.
Yeah, we get some reactions. Yeah, Manuel, it might be something related to your web browser. Maybe you might have some notifications on the top left or something to allow your web browser to use audio or something like that. I don't know, but yeah, since most of us are okay with audio, let's move on. So yes, what is LCA? Let's start with that. So LCA, or life cycle assessment in full, is a standardized methodology that allows us to calculate or assess the environmental impacts of any product or any system throughout its entire life cycle. In our case, this product or system is basically a building or an infrastructure project. It could be as well, but we're focused on buildings today. And its life cycle starts with the raw materials extraction, where you can see that A1 tag. So what does it take to extract limestone or extract iron ore or extract clay or any other raw material that will be used later to produce construction materials. Then we've got impacts associated with getting those raw materials to the manufacturing site. We've got impacts related to converting these raw materials into construction products. A lot of these impacts are related to the energy that we use and the type of energy that we use to manufacture this product, but also chemical reactions that are happening throughout the process. So carbon emissions for turning limestone into cement, for example, or iron ore into steel, and so on. Then at A4, we've got the emissions related to getting these construction products now from the factory to the construction site. Then we've got at A5 the construction process itself. So it's mostly energy related. So how much energy and what type of energy do we use to put all these materials together and build our building? And then we enter the use phase, which is B1 to B7 or B1 to B5, as we will see if we're looking to embodied carbon only. But yeah, it is related to impacts and carbon emissions associated to the maintenance of these materials, repair of these materials, or replacement of these materials when they reach the end of their service life. At the end of the use stage, we've got the end of life stage, which is the end of the life cycle of our building, which starts with deconstruction of our building, which you can imagine it as the opposite of A5. So again, energy related emissions mostly, energy that we will need to pull all those materials apart. And then what do we do with them? We have to take them from the site and take them somewhere else. So we've got more transportation emissions at C2. And then depending on what happens to them, we either have C3 or C4, which is turning them, recycling those materials or some of those materials, for example, turning steel scrap into recycled steel or disposing them into a landfill. And that's basically the end of it. In a tidier format, in a table format, which you will definitely see in any LCA methodology that you will want to follow in your project. We've got A1 to A3 at the beginning, we call it the product stage, then A4 and A5, we call it the construction process, then B1 to B7, you can now see the operational energy use and operational water use as well, end of life, and then separately the module D, which we always report separately because this is where we report the benefits and the loans beyond the system boundary. Like, what are the potential benefits if a future project uses some of our recycled steel, or what happens if a future project uses some of our steel columns or steel beams that we have designed for disassembly and made them very easy to be reused, and these kind of things. Hear me. I just got some kind of error from the platform, but yeah, if all good, I'll just crack on. So most of the regulations across the world, they have been focusing on B6, which is the operational energy use, which you have seen in the form of an energy efficiency billing regulation. That's not an LCA, of course. Then we've got an A1 to A3, which is also not that common, but it is a type of assessment when you want to look into embodied carbon. So you're looking to the carbon emitted or carbon emissions related to the manufacturing of all the construction products that have been used in your building. Then we've got the cradle to grave type of assessment, which is A1 to A1 to C4, and includes the whole life of the building. And then cradle to cradle, which includes module D, which is probably the most commonly used type of assessment. So when you do an LCA for a building, then you just go for the entire life cycle. It is slightly different with the case of LEED version 5, as we will see in the next few slides. And yeah, if we're looking to carbon emissions only, like global warming potential impacts, as we call them, but we exclude B6 and B7, which is the operational energy use and operational water use, then this is basically called the embodied carbon as well, because anything that is left is related to material related emissions. So that was the life cycle of a building and the different life cycle stages and modules. But what do we get at the end of the process? Like what kind of results do we get from an LCA? We said that we're calculating the environmental impact. So what kind of results are these environmental impacts? So because anything that we do as humans, like a product, a building, a service, a system, anything that we do, it affects the environment and it affects it in many different ways. We need many different indicators to communicate these environmental impacts. So it's not, well, it is possible, but it is quite challenging to come up with a single number that says, you've got that much environmental impacts. So instead, the standard practice is to have these indicators that describe the way that our building affects the environment in these different ways, and then we look into them all together. So there are many different indicators out there. This is just a list of the most commonly used ones, the ones that are being used in LEED version 5 as well. So we've got global warming potential, which we mentioned already. This is related to the climate change and the carbon emissions or any greenhouse gas emission that contributes to greenhouse effect and in this way to the global warming. This is where we capture these impacts. Then we've got acidification potential, which is the potential for the soil to be acidified, for example, through acid rain, eutrophication potential that describes the eutrophication of water systems, and so on and so on. We're not going to go through all of those simply because global warming potential is the one that we focus the most because that's the most pressing challenge, at least at a global community. It sounds a bit strange to say this at these times, but as a global community, global warming and climate change is considered one of the most challenging issues nowadays. So we're focusing on global warming potential. Yes, so embodied carbon, which is a term that we very often hear, is, as we said, the greenhouse gas emissions that arise from the manufacturing, the transportation, the installation, maintenance, and disposal of building materials. It's basically an LCA that ignores the operational energy and operational water use. And how do we calculate those numbers? So this is something that you don't need to worry too much about because it is happening in the background in the data that we will use. This data is called environmental product declarations or EPDs. So what happens in these EPDs is that a manufacturer, let's say a steel manufacturer, they will do an LCA for their product. They know what kind of emissions they have when they produce their product. And then there is something which is called characterization methodology that will convert all those different emissions into an commonly agreed unit. For global warming potential, this is kilos of CO2 equivalent. Again, you're not going to apply this unless you're going to do like a product LCA, but when you're doing building LCAs, you don't need to worry. This is just background knowledge, really. So how does this work is that we've got a factor that will convert a kilo of CO2 into, well, obviously a kilo of CO2 equivalent. But for methane, for example, that would be 1 kilo of methane converted into some 30 kilos of CO2 equivalent. So we translate everything into kilos of CO2 equivalents because that's the most contributing greenhouse gas out there. There are a few different methodologies to do that, like CML and Tracy in your region and most parts of the world. I mean, the entire world except for US and Canada, we're using CML or PEF, which is like a new methodology that is being used nowadays. And in Northern America, manufacturers, they're using a different methodology, which is called Tracy. We don't need to worry about it because when you're using OneclickLCA and you choose the tool that is appropriate for your rating scheme and your region, then it only gives you access to the right data. So this is also some background knowledge. I mentioned environmental product declarations already. This is a product LCA. It is an LCA that the manufacturer will do for their products. So we then, as sustainability consultants, architects, structural engineers, we can use and do these calculations. The calculations concept is extremely simple. It's basically our material quantity times a carbon factor or other impact factor. It's a simple multiplication. Well, it's a very simplified way to put it, but it is something like that. It's always some kind of multiplication. So what do we do? What do we get from these EPDs is a table that looks like that. So we're looking into the global warming potential total. This means that in order to, sorry, I'll just go to the fossil so I don't confuse you with the negative numbers. I will explain probably a bit later. But global warming potential, this means that we need to emit 3.5 kilos of CO2 equivalent in order to produce this type of product, which is probably like a square meter of this hollow core slab or anything like that. So this is how we read environmental product declaration, or this is how an LCA tool will read it and do all the math for you in the background. Before we proceed, are there any questions from the audience, Anania? Anything that we can take now?
I think we can just move
Okay.
on. Yeah.
All right, awesome. So LCA throughout the design process. So this is something that really can be used as a decision-making tool, as a design tool. So it's not just we design everything, we build everything, and then at the end we will calculate how much embodied carbon is there in our materials. It might be a good thing to know, but you cannot change it. So we need to start early, and we need to keep working on it throughout the design process with the aim to push the results down, push those impacts down. And there's a lot of different features in OneclickLCA. We will explore a few of them today. For example, when we are involved in the concept design stage, we can use Carbon Designer 3D, which we will demonstrate today, which is a tool that can give you material estimates based on the size of the building and the number of floors below and above ground and the type of the building and the region. So you basically don't need any design documentation. Then we've got all these different integrations that we mentioned earlier. We've got features that help you to compare different products or different materials with each other. And then there's plenty of other tools like the circularity assessment tool, if you want to couple LCA results with circularity as well. If you're aiming, for example, to make a fully circular building that could be disassembled in 60 years and reused. So there are some metrics that can communicate this as well. And yeah, of course, we keep building more and more features with the aim to make it easier for our users, engineers, architects, and consultants to really reduce embodied carbon in their projects. So this is our main aim here. We're trying to enable the makers of a zero carbon future, as we love to say. That's our motto. So it's not just an accounting tool. Don't take it this way. It is a design tool. It should be used as a design tool and as a embodied carbon reduction tool throughout the design process. As I said, we will see just a few of those features in a little bit. So rating schemes, there's plenty of them, as you probably know. Rating schemes, they have been the main driver for life cycle assessments across the world. We've got LEED that we will discover today. We've got BREEAM. We've got several other rating schemes, Green Star and Living Building Challenge, and anything like that. Some of them are more popular than others in different regions and so on. But the one thing remains the same, that they have traditionally been the main drivers for LCAs in building projects. This has started to change in some regions. For example, in Europe, so in Europe, we can now see regulations being formed and being mandated. So we now see regulations take over from rating schemes, which is probably the next natural step in the process. So most regions will start applying LCA voluntarily because they need, because they're driven by rating schemes, and then we've got these requirements being incorporated in the building regulations or in some countries. And yes, looking into LEED specifically. So what are the requirements, or what has changed? As you might have heard, we now have a new version of LEED, LEED version 5. So the LCA requirements have changed slightly as well. So it is now mandatory to do an LCA for modules A1 to A3, which is the first time in the case of LEED. So usually, previously it was just an optional exercise. Now it is mandatory. You have to do it, and you don't get any points for that. You just have to do it. And then you will need to do some extended LCA, let's say, in order to get some additional credits. So you do the mandatory part, and then if you expand to a full life cycle assessment and you're able to demonstrate some kind of impact reduction, then you get some additional points. And we will see what that means. I'll just skip that, because that's as we said, the mandatory scope. Very simple, A1 to A3, and this is it. And you have to do it for the main materials, actually, the main primary materials like concrete, steel, and masonry, and any other material type. If you consider it as a primary material for your project, then you have to include it. So there's no strict description of what you should actually include in your assessment. Just you do an assessment on your own and you add it. So the idea is that you do some calculations, you identify hotspots so that you know what you can change or what you need to change throughout the design process. Now, the extended version is a full life cycle assessment. So that requires you to include the entire structure, the entire envelope and enclosure in general, and hardscape materials. And then it gives you some additional points. It gives you 2 points for just doing the extended um, scope, and some additional points depending on the impact reduction or global warming potential impact reduction that you will be able to achieve. So, example, 3 points if you achieve 10% reduction, 4 points for 20%, 5 for 30, 6 for 40, and 7 points for 50% reduction, which is quite challenging, especially for fully new construction. That's the entire scope. As we said, well, it's not really entire because it excludes B6 and B7 and module D, but it captures pretty much all the material related emissions, at least, which is the point here. This is what we're trying to optimize. And then you also have to report in additional indicators. So not just global warming potential, but also depletion of stratospheric ozone layer, acidification, eutrophication, and a couple of others as well. If it sounds complicated, I understand, because when you see lots of these kind of words, tricky words, it might sound complicated if you're a beginner in this, but don't worry, because when you're using the lead tool in OneclickLCA, all this is basically automated. It creates all these calculations, it does all those calculations, it creates all these compliant results for you. It gives you the results so you can actually focus on analyzing the results and identifying alternatives or impact reduction strategies. And we will see this in practice in a little bit. When it comes to the physical scope, like what we need to include, as we said, it's the structures like foundations and superstructure, including columns, beams, and slabs. Then the envelope, including the external walls, windows, doors, and the roof construction, and then the hardscaping. So we basically don't add MEP systems and finishes as well. Yeah, then some quick reference on early design stage LCA, but I think there is one question from Anam on whether there is a reduction target for other impact categories apart from GWP. No. LEED, just like most other LCA methodologies or rating schemes, it focuses on global warming potential. It still requires you to generate the results for other indicators and analyze them. But yeah, there's no any target for that. The target is entirely for global warming potential. So early design stage LCA, just a couple of slides to set the scene before we move on to the demonstration. The decarbonization potential, as we say, it basically halves at each design stage. So as we move on, we lose on opportunities to reduce the embodied carbon. And that's the case with pretty much anything in a building design. You're losing your ability to change the shape. Once you finish the concept design, I mean, the shape is fixed and you're working on some more detailed items. You're not able to cut significant costs as well because everything have been decided already. So you're basically just working on the details. It is exactly the same thing with life cycle assessment and environmental impacts. Of course, you can change things later, but the cost is huge. So you cannot wait until the specification stage to suggest any change in the structural frame, for example, or even more the building shape. So these things must be addressed at the beginning. I mean, you can even look into different sites and how the site can affect the whole life cycle impacts as well when you're at the strategy level. But when you start at the concept design stage, you look into building shapes. You can look a bit later, you can look into structural frames. structural materials, types of slabs. This is then when you start doing an LCA to comply with rating schemes or other regulations and policies and methodologies. And then as you move on, you're losing the ability to influence the life cycle emissions, but you can still actually run iterations, LCA iterations, and keep reducing these embodied carbon because you're looking into smaller things. For example, comparing different types of insulations, for example, or comparing different types of windows. And as you move on, you look into further details, like how does this product compare to that product? They're basically the same thing, but from different manufacturers. Who can give it to me with lower embodied carbon? So it is a continuous exercise. It's not like something that you do at the beginning or at the end. It has to be something that you use as a design tool. And with that, let's move on with the live demo. We will need to stop sharing the presentation while I'm preparing to share my screen. I will do that now. All right. Yeah, I believe that my screen is now visible. So, yeah, we don't have enough time to go through every single detail, but basically this is what we see here is how a building LCA project looks like in OneclickLCA, which, by the way, is an online tool. You just need to create an account. You don't need to download or install anything. I have created this project already for this demonstration. It's an imaginary building in Canada. I have added this tool. As a reminder, OneclickLCA is a platform. It's not a single standalone tool. So you add different tools that help you comply with different policies or methodologies or regulations. In this case, I have added this single tool to comply with LEED version 5 in North America, and I'm using metric units. Things in North America are a bit more complicated because of the units and all the different standards that they use, but the rest of the world, it is basically the same. So yeah, you don't need to worry about. You might ask why I'm not using an example in Kuwait. This is because there has been a lack of guidance from USGBC for some time on how compliance will be achieved for LCA outside the US and Canada, simply because in their first version of the manual, they specified indicators that cannot be achieved outside the US and Canada because, again, of the different standards. So we are now that we've got some clarifications, we are developing this tool, which will be released in a couple of weeks. But it will look exactly the same. It's just the data that will be available that are different. There will be more data actually in this other tool because the data are the same in the entire world except North America. So I'm closing the parentheses. So let's move on with the demonstration. I've got this tool here. I've got this design here. I'm not going to show you this design yet because I want to start with an imaginary scenario where we want to start early at the concept design stage. So we don't have any design documentation. We only know the size of the building, and that's it. So what do? We will open this tool, which is called Carbon Designer 3D. This will take us in a completely new interface. We will create a design, which we can call it baseline. Let's assume that this is an office building. There are some reference buildings here, which is basically our way or OneclickLCA's way to make those material estimates. So, and match them with different products. So they're different for different regions and different building types. I will keep it simple and move on. We said we're doing a lead assessment, so we will uncheck the boxes for finishes and services. So we want to include foundations, the ground slab, structure, and enclosure. Our frame, we expect this to be in situ concrete, which is like a quite typical baseline in most of the countries. We can add some piling as well, some 10 meters deep, although we can change it later as well. And then there's a few different ways to define the shape. The easiest one would be to say that this is a rectangular shape. We define the gross floor area, total gross floor area, and the number of floors, and it will make it will generate some geometry. We can have AI generate multiple geometries, and we choose the one that we think is better based on the site restrictions, or the free drawing, which basically means that we will model the footprint of our building. We will add the gross floor area and the number of floors, and then we can tailor it a little bit. I'll just go simple for today because we don't have much time. So let's go with a rectangular shape. Let's say 10,000 square meters, 5 floors above ground, and 1 floor below ground. And yeah, just like that, we get an imaginary building. It is imaginary, and we're fine with that because we're supposed to run this exercise at the beginning of the concept design stage. So we don't have any design documentation. We just know how big this building will be and how many floors. There might be some height restrictions, so we can tell from that. We can change the shape if we want. Let's not do this today. We can calculate the element quantities, for example, the ground slab, the staircases, the columns, the floor slabs. Based on the reference building that we chose, it has generated all the other elements. As we can see, there's a frame and slabs and so on. And then we go to the next step. I will skip this because, or maybe I can give a quick description. So this is where we can override the reference building. So if you don't like the OneclickLCA's reference buildings because they're not that relevant for your region or the type of the work that you do, you can create your own reference buildings. And this is where you can override by applying a template to the reference building. But this will definitely take some time to explain. So let's leave this for another time. So we submitted without template. And this will now calculate the material quantities, assign them to actual products or average products, and it will give us the results directly. We can activate the carbon view as well. That shows us where most impacts are coming from. As expected, most of them are coming from slabs and the roof, and then the columns and the beams and the foundations. But yeah, in a bit more detail here. Again, floor slabs as expected, beams, then roof slabs, then windows, and so on. We can scroll down and we can see all the assumptions. For example, for the ground slab, we can see that the assumption is that we'll have this type of slab. And for the structure, columns, we've got 350 by 350 concrete columns. We can change all those assumptions to something different. So if we think that, this is too thin columns, let's just go with something bigger. We can go with something like that. So 100% of the columns are 400 by 400, and the rest, we'll need to set it to 0. So you need to spend some time here to make sure that what you got here is a good representation of an average building in your region. And what do you do then? You've got your first baseline, your first benchmark. So you now need to start reducing this embodied carbon. So how do we do that? We will need to make a copy of this. So let's call it improved because we want to improve it. We can now see that we've got two set of results here for two different buildings, same geometry, same materials, but the idea is that we got the improved design now and we start assessing different options. So what would it be if we change the floor slabs into some other slab type, for example, from flat slabs to hollow core slabs, or we completely start over with a completely new design with a different shape, different geometry, or a different structural frame. We can probably apply it very quickly. Improved to yeah, as a quick demonstration of how quickly you can actually do things in Carbon Designer. Let's go with yeah, CLT might not be the most popular for your region, but we can apply some other changes as well. So CLT, and we can also very quickly check the free drawing capabilities as well. We will apply some building footprint. We'll generate the 3D view. So our building will now look something like that. And we can drag and drop. We can drag those points as well to do any change. I mean, yeah, I'll just generate as usually something very, very ugly just in order to make a point. So that's how you can generate different shapes. And let's see what difference that makes. We will calculate the areas. We go to the next step. We don't apply a template. This will take us directly to our project. And well, yeah, we didn't put much thought on it, but yeah, we managed to, let's say, to reduce the embodied carbon, or at least carbon emissions per square meter, because we are not that careful to make sure that these buildings are also equivalent in terms of size. But per square meters, that seems to be like a lower carbon, probably mostly because I added a timber frame, which leads me to another thing. Yeah, do those changes one by one so you know what actually affects what. I should have created a separate design with the same shape with timber, and another one with probably either timber or concrete, but different shapes. So I can tell then that going from a rectangular shape to a shape like that increases the embodied carbon by 20%, which is usually the case. Like the more complicated geometry, the more materials, and the more associated carbon emissions. Yes, and once we're ready, we can let's say this design, the input one, we can send it to our main project, and we can keep working there. We can replace those material quantities with actual material quantities from the actual design when we get the first drawings or the first big models. So we can see how it looks. Yeah, we're back in the main tool in the project page. That's the design that I had created beforehand as a preparation, and this is what we just added. We'll need to add some more data like the building area and things like that. But yeah, essentially, yeah, let's just quickly look at how this looks like. So we basically get a single list of all the materials. We can get them better. We can get them by element type. So for example, we get all the foundations here, like the reinforcement, the ready-mix concrete, the actual quantity. We can change it if we want. Let's not do any changes here. We can add more materials. For example, if I search for concrete, well, there's a typo here, but it should still give me some results. We'll get loads of concrete data points to make sure that we get results that are relevant. We'll apply a filter for the country as well. There are some other filters as well, like whether we want to find some generic materials or manufacturer-specific EPDs or anything like that. Local generics, local EPDs. We can see there's like an abundance of concrete EPDs in Canada. We can check the environmental profile like that. So this has 163 kilos of CO2 equivalent per cubic meter. We can see the full ranking, like checking if there's any better material than this. I actually chose a very good material in this case, so I don't think that I will be able to get many better materials. Yeah, that's the state of Ontario, then the whole country, and then the rest of the world. So yeah, let's very quickly see anything that is better than the median. And so all products that are better than the median. Although this is a bit for later stage, but yes, I wanted to show you some highlights. So this will generate, so yeah, there we are, a list of manufacturers and their declared impacts for their products from the lowest carbon to the highest carbon per cubic meter. So yeah, we can choose the one that suits our needs. With that, I will go back to the main project page in order to demonstrate very, very quickly, because we're running out of time, the lead version 5 workflow. So I have already created this test project right here. What I'm going to do, which is supposed to be the baseline project, I basically use Carbon Designer 3D to create it within a couple of minutes. So the idea is that once we have the baseline, excuse me, we will make a copy. Let's call it the proposed design or improved design. This will create a new design which is identical, but we can then go to, sorry, this one. We can go to the building materials. I'll just make one single change because we don't have enough time, unfortunately. But let's see where most of our impacts are coming from. We'll take those categories one by one. We can see that, yeah, some of them are kind of significant or big impacts, like this one, 3% of the total impacts. But I'm pretty sure that when we go to the slabs, that number will increase. So what we see here, actually, yeah, I should have mentioned that, is how much this specific material contributes to the overall results. And that means, yeah, 5% for this. We can move on. I'll just go straight to the floor slabs because I know that it's going to be quite big numbers. So we can see here there is this concrete quantity that's responsible for 19% of the total impacts. So just do a change for this only. What I can do is to click here and replace this resource. That's a C30. So just look for C30. That was the average data point. I'm also looking for Canadian data points only. So let's just go with that. Maybe some local generics. Let's apply some other filters as well. So yeah, there we are. I was just looking for these generic data points from OneclickLCA. So what I'm going to do is to replace this baseline concrete mix with something that has 50% recycled binders. So let's replace with this resource, and that dropped it to 10% from, what was it? I believe it was this one with 10%. So if we now go back to our main project page, and recalculate the results, we can see that there is a slight drop. We can also see it here. It's a slight drop because we only changed like one material. But yeah, the idea is that we will now go through all the other materials, and yeah, because there's plenty of concrete data points actually in many different parts of the project. So we change this as an idea as an improvement strategy, and see what difference it would make if we were changing from 0% recycled binders or whatever the baseline was to something like 50%. And then we can see that, yeah, it creates some 20% or 30% reduction. And then according to that, we can make an estimate on how many points we will achieve for this lead project. And with that, I think
Marius,
that's,
while
yep.
you're actually here on the impact categories, there's a question
Mhm.
specifically on this, so I think might be good to ask it here.
Yep, of course.
Anam asks, I would like to clarify that for the other impact categories in V4 and V4.1, the credit specifies that the proposed case should not exceed 5% in these categories.
Mhm.
She's asking if we could confirm whether this requirement is applicable for lead V5.
No, there's no sets requirement in version 5. There's only GWP reduction targets. I remember that requirement, but there's nothing like that. So you only need to report on the other indicators. There's no constraint. And I see there is one more from Abdullah. Not sure if this is a question.
I think he was just responding to Anam.
Okay, all right. Okay. Yes, yeah,
Yeah,
that's good.
and there's one
Uh,
question from Marvin that says, what is the case when there are green rating systems that do not require LCA?
well, in this case, you're missing this extra driver for doing an LCA. So yeah, it's entirely voluntary then. I mean, I hope that you see the value in it. Well, we use some very rough examples in this, like 20 minutes of demo. But in real life, it's a very powerful tool because you can communicate things to your client from the very beginning. You can suggest reduction strategies and support them with numbers, and use this as a decision making tool. But unfortunately, it is voluntary. So you, as an engineer, architect, or consultant, you might have to do it voluntarily because you believe in it, or you might be able to convince your clients that this is a good thing. So yeah, they provide you these additional fees that you need. Plus, I mean, we continuously improve the tools and we make the process more and more efficient. So yeah, the associated fees are also, and the effort, let's say, is being reduced as well. So we're trying a lot to make it as easy as possible so that everyone can do it in a very small amount of time. But yeah, the short answer is that you're missing basically this driver. It's completely voluntary afterwards. And yeah, with that, if there are no more questions, I believe there were like a couple of slides that were left. Are they still visible? I believe they are. Okay. So yeah, question. If I hope that you took some good first taste of the tool and its capabilities and LCA in general. If you want to talk more about lifecycle assessment, do fill in this quick poll that is in your screen right now, and then someone from our team will reach out to you for a private demo. I believe that should be enough time for a simple question. An announcement. If you need more training, we are going to have these free LCA and EPD bootcamps this month. There are links. So when we share the slides, you will be able to check the links. Otherwise, you can just go to academy.oneclicklca.com, and they're like in the first page, a construction LCA bootcamp and an EPD bootcamp, both this month. And yes, finally, a case study in your region. So Dalal, over to you.
Thank you, Marius. Thank you for explaining the entire concept, also showing us the demo. We just wanted to share an example of how, especially for our audience from Kuwait, that how LCA is used in Kuwait. We've seen there's not many projects that are using LCA, but I would want to share more details on this project. This is Jabr Mall. It's a very large mall. It's under construction, under the last phase of construction. We expect it to be fully operational by the end of the year. The developer of the project wanted to pursue LEED, so the project is targeting LEED certification under LEED 4.1. And during this project, the consultant has used lifecycle assessment, and more specifically, OneclickLCA. And it was a great tool for us to understand all the embodied carbon, but the operational carbon in such a large-scale development in Kuwait specifically, and then find ways to mitigate that very early on in the design phase. And this helped us get 11% reduction in global warming potential, which is higher than the LEED requirement, which is 10%, but also helped us target 3 additional environmental impact indicators that were mentioned by Marius. And overall, it made the project eligible for 3 points LEED credits in material and resources category. So just to encourage anyone who's listening from Kuwait, like there are adaptations for life cycle assessment, and it does have a positive impact, especially if you're pursuing a LEED certification for your building. Yeah.
Right, thank you very much, Dalal. And yeah, I believe that must be it for today. We run out of time by a few minutes, apologies for that, but let's see if there are any final questions before we wrap up. I see there's one question from Anam about the difference in the version 5 and version 4 tools in OneclickLCA. The main difference is the data that you can use. So version 5 now, for outside the US and Canada at least, it now aligns with the plus A2 version of the EPD standard, the EN 15804 standard, which is different than it used to be. So previously the indicators, they were aligning with the A1 version, so there were not that many EPDs that were still active. So that has changed. And yeah, there are then some other minor details, but yeah, that's the main thing basically. And yeah, I guess with that, we can wrap up. Thank you very much, Dalal and Kuwait CBC for the invitation. Thank you everyone for joining.
Thank you, Marius. Thank you, Ananya.
Thank you all. Bye-bye.
Bye.
Bye-bye.